All right, let's jump right into a pretty wild idea. What if our buildings, the very things that make up our cities, could go from being part of the climate problem to being a key part of the solution? It sounds a little like science fiction, I know. But today we're going to dig into the very real concept of turning our buildings into massive carbon sinks.
So, here's how we're going to tackle this. First, we'll frame the central question: are buildings a problem or a solution? Then, we'll talk about the material that makes all this possible, and its two superpowers. After that, we'll get into the economics, because it has to make financial sense. We'll also be real about the hurdles ahead, and we'll wrap up with a pretty cool vision for the future of our cities.
All right, so first things first, let's set the stage. Are our cities always going to be major polluters, or can we imagine them as something completely different?
Let's just lay out the fundamental shift we're talking about here. Right now, our buildings are huge carbon emitters. A big reason for that is the process of making steel and concrete. It's incredibly energy intensive. But the future we're exploring is the complete opposite of that. Imagine buildings that act like carbon safes, locking away CO2 that's been pulled from the atmosphere. So the big question is, how on earth do we make that leap?
Well, the answer, believe it or not, lies in a material we've been using for thousands of years, but are now giving a high-tech upgrade: engineered wood. And when it comes to fighting climate change, it has what you can call two superpowers. Okay, superpower number one, it's something called biogenic storage. And the logic behind it is actually beautiful in its simplicity. You know, as a tree grows, it literally breathes in CO2 from the air. When we harvest that wood and use it in construction, we're basically taking all that captured carbon and locking it away inside the walls, floors, and beams of a building for its entire life. So you see, it's this amazing natural cycle that we're just harnessing for a new purpose. A tree sucks in CO2, we use the wood, and then that carbon gets safely tucked away in our cities for decades, maybe even over a century.
All right, you ready for superpower number two? This one is all about what we're not using. It's called material substitution. And just think about it for a second. Every single beam of wood that we use is a beam of steel or concrete that we didn't have to make.
And this is the real kicker, because making those traditional materials pumps out a ton of emissions. So what you get is this incredible double victory. You're storing carbon that's already out of the atmosphere, and you're preventing a whole bunch of new emissions from ever being created in the first place.
So what does that double victory actually look like in practice? Well, the numbers are pretty mind-blowing. When you combine those two effects, the storage and the substitution, you could potentially slash a building's carbon footprint by up to 73%. I mean, that's not just a tweak, that's a total game changer for the entire construction industry. Okay, this all sounds great, right? But for this whole revolution to actually happen, it's got to make financial sense. So let's talk about the money. How do you turn a building full of stored carbon into a financial win?
And this is where it gets really clever. The carbon that's locked inside a building's wood structure can be measured, it can be verified, and then it can be sold on the open market as a carbon credit. You're literally turning an environmental good deed into a tangible financial asset.
Now, you can't just slap a price tag on this stuff. For this whole system to be legit, it has to follow some super strict, science-backed rules. Think of them as the 3 golden rules. First, there's additionality, proving you chose wood when you could have used something else. Then, traceability, making sure that wood comes from sustainable forests. And finally, permanence, a solid guarantee that the carbon is going to stay locked up for a very, very long time. And here's the payoff. When you follow those rules, the money part starts to make a ton of sense. So yeah, engineered wood might have a slightly higher upfront cost than steel or concrete. But that's not the whole story. Once you sell those carbon credits and subtract that value, the net cost of the wood drops a lot. It becomes totally competitive, and sometimes it's even cheaper. Oh, and it gets even better. There's another huge financial benefit. Because a lot of these advanced wood structures are prefabricated in a factory, putting them together on the construction site is way faster. We're talking a 20 to 25% drop in construction time. And in the building world, we all know what that means. Time is big money. And don't for a second think this is some small, niche idea. This is blowing up. Projections show this becoming a $12 billion market in the US alone by 2034. We are literally watching the birth of a major new green industry. Okay, but let's be real for a second. It's not all sunshine and roses. For this vision to become our everyday reality, there's some pretty big hurdles we still need to clear. Probably the single biggest challenge is the end-of-life question. What do we do with all that carbon-storing wood when a building gets demolished in, say, 100 years?
We've got to have a solid plan so that carbon doesn't just get released back into the atmosphere. And at the same time, the carbon credit market itself is still kind of new. It needs clearer, globally accepted rules to really build the confidence that big investors need.
So yeah, there are challenges to solve, no doubt. But even with those hurdles, the core idea here is it's too powerful to ignore. So let's wrap this up with one final thought that really brings it all home.
I mean, just think about it. The simple idea that our buildings, the very symbols of modern civilization, could be made from a material that literally cleans our air while it grows. That's revolutionary. Which leaves us with a really fascinating question to chew on. Could the future of our cities, instead of being extracted from mines and quarries, actually be cultivated in a forest?